Test. Hello? So, how many of you know RxJS or ever used it? Nearly everyone. How many of you know schedulers? Some. And how many of you ever used a scheduler? 2%, something like that. Well, if you use RxJS, you use schedulers anyway because they are baked into RxJS. Let me give you some overview why this is important. As I said, schedulers are baked into RxJS. You could fix your slow-running animations with it. You can also schedule tasks as async events, and most of all, knowledge is powerful. These are some reasons why you should care about this talk at schedulers. Let's start with a question. What is the execution context of an observable? I asked this question on Twitter. About 500 people answered, and the most voted answer was, what the fuck is execution context? If you look at the rest of the answers, you will see there is not a lot of difference. This is a proof that this question is really not easy to answer, and obviously I will help to answer this today. If we look at this code, we see on the left side some lines. I use request animation frame, I use set timeout, I use a promise, and then a synchronous console log. And if you compare these lines with the other side, the console output, you realize that they occur in a different order. Which means that if I wrap something in a set timeout and it is executed asynchronously, it will be executed after the synchronous code, for example. This is what I mean with execution context, so the context in which my console log, in this case, is executed. Let me add another line of code. Let me add this observable here, and if I subscribe to this observable, you will see that it is logged at the first place in the console part, which means observables are synchronous, right? Not really, because, for example, I could apply a pipe that is called observe_on, and I pass an async scheduler in, and then you will see that the same code is executed as it would be wrapped in a set timeout, so asynchronously. For most of us, this is kind of confusing, and I will give you more in-depth knowledge what you can do with this, and hopefully it will unconfuse everything. My name is Michael. I do my living out of workshops, consulting, and I'm very active in the community. What I do is I provide workshops and consulting over Angular Colleague platform. I run Angular Austria together with my colleagues. I guess some of them are here today. Is some of my colleagues from Angular Austria here? Miro is here, for example. Michael not. Okay, so I would expect 2 people here. There's only 1 other person, but okay. And then I also run Angular Vienna, which is one of the biggest meetups in Austria. And furthermore, I'm working on NG Spain together with my lovely colleagues, Anna and Sherry, and a lot of other people that are not here today. But enough advertisement. Let's talk about what's on the menu. I will show you the responsibilities of a scheduler, the basic usage, the different types of schedulers, the internal building blocks, so what's happening under the hood, and then I will show you how to use a scheduler manually. Let's start with the responsibilities. What is a scheduler? A scheduler is a piece of logic that helps you to parameterize where, when, and how code is executed. Let me divide it in 3 sections, in 3 blocks. The execution context, the execution policy, and of course the inner clock. And I will start with the execution context. So Execution context, as I showed you in my first code example, is the way how code is executed. Is it executed asynchronously as a macro task or as a micro task? Is it running on an animation frame? And so on. And schedulers basically control the execution context of observables. Then, if you want to control execution context in vanilla.js, you have to wrap your code into some function. If you compare this with RxJS, it is obviously super convenient. You just provide another parameter, you just apply another pipe, and you can control or switch the execution context of your whole code without changing it, without wrapping it in another function. So really, really cool to use. The execution policy controls the order in which the events are executed. And how to control order in JavaScript, we use arrays, because arrays compared to an object has an order, right? If we look in the source code, we see that a scheduler internally holds a variable called actions, which is an array of actions, and then a flush method, which basically runs all these actions in the right order. And the last part that I want to talk about is the clock. Schedulers help us to schedule some tasks at some point in time. And if you want to do something at some point in time, you need notion of time. Therefore, scheduler need some internal clock. How does this look? In the source code, a scheduler internally holds a function that is called now. And now returns you a number. Normally it will return date.now, so the timestamp, but it can return any number, not even related to our real time. That's it. Now let me give you some examples how you can basically use schedulers in a simple way. One way of using it is, as I showed you before, you can apply the observe on operator, and you can provide, in this case, a queue scheduler. Observe on operators control the emission of events, and you can apply multiple of them in one stream. Another option would be subscribe on. Subscribe on is controlling the time when the subscription happens. And then you have furthermore options. You can also provide schedulers and a delay on intervals, ranges, or whatever, and specify the execution context of this, for example, interval here. You already realized that there are different types of schedulers. So let me give you a quick overview of all the different types. There is the queue scheduler. The queue scheduler holds a queue of actions and schedule them one by one synchronously. Then we have the async scheduler, which falls back to a macro task. So it's pretty similar as you would wrap your code in a set timeout or in a set interval. Then you have the as soon as possible scheduler, and this is the case, or it is comparable if you would wrap your code in a promise. And in the end, you have the animation frame scheduler, and this scheduler schedules your actions right before the next paint event of the browser. There is a second group of schedulers. On the right side, you see virtual time scheduler. Virtual time scheduler eliminates time. So if you apply this scheduler, no matter how long your delay is, you will schedule all your actions in no time. And there is another special scheduler, there is the test scheduler. And the test scheduler is a helper for testing observables, for testing Rx. I gave you an overview of all the schedulers. Now let's use these schedulers in some code, and let me give you some more insights what you should care about. If you look at this code, I have two variables, a delay, an observable, and then I subscribe multiple times to this observable, and every time when I subscribe, I use another scheduler. Animation frame scheduler, async scheduler, as soon as possible scheduler, and queue scheduler. If you look at the console, you see what you would expect, that code is executed in the order as the execution context fires. The important part here is that I provided a delay of 0 milliseconds, because a delay is another optional parameter that you can use in your, for example, observe on operator. Now let me change the code a little bit. What I did now is I only changed the delay from 0 milliseconds to 1 millisecond. And if we take a look at the console now, we realize that all our console logs, no matter which scheduler is used, are executed as they would be wrapped in a set timeout. No matter which scheduler. What does it mean? It means that internally, Rx, or a scheduler in Rx, falls back to an async scheduler if you provide a delay. This is something that I had to explore painfully, and only after some reverse engineering, I realized the problem. I tweeted about this because, as I was saying, I'm pretty sure if you're using animation frame scheduler, you're using it in the wrong way. Most of the people, and also I, used it like this. I create an interval, then I use 60 frames per second, and then I say I will run this interval on my animation frame scheduler. And I was expecting a smooth and clean animation because of the animation frame scheduler. In fact, this was not the case. So if we take a look in the source code, we see that animation frame scheduler, or action in this case, is extending async action, and if I provide a delay that is other than 0, it will automatically fall back to the async action. So there is no chance to use a scheduler with a delay that is different from async. Let me give you some more example that we really realize what it means for us. And therefore, I created this small demo that I will explain now. Perfect. So, what is this? This is a small web component, and I have 3 circles, a blue, green, and a red circle, and all the circles are animated over Rx. For the red circle, I use the queue scheduler. For the async scheduler, I chose the color green, and the blue circle is the animation frame scheduler. Then I have 2 values here. One value specifying the distance, how far the circles will jump on each animation. So if I increase this, you see they jump a bit further. If I increase or decrease the milliseconds, you see that the tick is different. Now let me decrease the milliseconds to 1 millisecond. And now, please watch the blue circle when I switch from 1 millisecond to 0 milliseconds, which is now. And now I switch back. And now back to 0 milliseconds. So this is a visual proof that something is different if I provide 0 milliseconds. In this case, I really run my blue animation on the animation frame scheduler. Before, with everything else than 0, it was not the animation frame scheduler. Let me give you another proof that this is really the animation frame that we are running on. To do this, I need to stress my browser. And when I was working on this demo, I spent hours to create some functions that put my browser under pressure. And after some hours of coding, was not really working out for me well, I realized that a very easy way to stress my browser is if I just resize my window. So, some hours wasted, now I know how to stress the browser. And if I stress the browser, please watch the blue circle. It stays in its steady speed. It is a little bit flaky, but not too much compared to red and green. And if I stop the stress, red and green are jumping back to their as fast as possible speed, and the blue circle stays nearly in the same speed. So this is another proof that we can run smooth animations over the animation frame scheduler only if we apply a delay of 0 milliseconds. Good. Let me switch back to the slides. Now let's dive deep into the source code. What is happening internally? I will talk about 4 building blocks. And I will explain a scheduler as something that schedules or executes work at a specific time in a controlled execution context, and I can also unsubscribe from this scheduled work. Let me start with work. What is work? Work is just a function that gets executed. Nothing special, a function that takes some parameter and then is doing something. In my case, I just console log the state that I provide here. Next building block is an action. What is an action? Whenever I talk about actions, I explain them as the execution context of work. So work is wrapped in an action, and then I can call the schedule method on this action. This schedule method returns me a subscription, and as you know, I can use a subscription to later on unsubscribe from this code. What is the next building block? A subscription. Subscriptions are pretty familiar for us, at least if we use Rx. And if I subscribe on an observable, I get a subscription returned, and I can unsubscribe from this subscription later on. If I use a scheduler and call the schedule method, I also get a subscription returned, and I also can unsubscribe from it. Let me give you some more details on the subscription object. We could use it to nest subscriptions. How do we do this? In this case, I schedule an action, I create one subscription, I schedule another action, I create a second subscription, and then I use the subscriptions add method to nest a second subscription into it. And later on, I can call unsubscribe from my first subscription, and I will immediately unsubscribe from all nested subscriptions. This sounds like a pretty useless feature, right? But if you think about actions and that we could fan out actions, we could schedule actions within actions within actions, then finally it makes a lot of sense to have this method here. Because then we have a single point where we can control all our nested scheduled actions. Okay, we know what work is, we know what an action is, we know how a subscription works and that we can nest subscriptions. Let me show you how to use a scheduler. First, I show you how to get an instance, then I show you how to set up some work, and schedule this work. First, let me show you how to create an instance. You could use the new keyword, and you can create a new instance of the queue scheduler, for example, and you have to provide the class of queue actions, not an instance of these actions, but the class itself. I would not suggest you to do this. I would suggest you to use some predefined schedulers that you can use straight away that are provided from the library. Next, we need to set up delay, state, and work. Delay that specifies the delay, some initial state, and some work that is executed. And then I can use my scheduler, and I can call the schedule method. And I will use work and state to create a new action. This action is later on executed after some delay. As I told you before, when I call the actions schedule method, I get a subscription returned. This subscription is forwarded to the scheduler's schedule method, and then the scheduler's schedule method returns me this subscription, and I can use this subscription to later on unsubscribe from it. This is more or less what happens inside of a scheduler, at least in RxJS 6. Good. Now it's time for some more live demo. Okay, these are two signature pads. And if I use this device here, I call it finger, and I draw on my screen, you see that I can draw a line on this signature pad. The goal is to animate the drawing from the left side on the right side in real time with the specified delays and with all the breaks that I do. This drawing, this signature, consists out of different things. A signature consists out of segments. What is a segment? This is a segment, this is a second segment, this is a third segment. And every segment consists out of points. So if I take a look at my console logs, I can see that a point here, let me quickly zoom in a little bit, that a point defines color, the time when the action of this point happened, and an X and Y coordinate to place it at some specific point on my drawing pad. And the goal is to iterate, to iterate over all these segments and points and animate it on the right side. So let me jump into the code. Here I have my signature, I have a for each loop, and I iterate over each segment. And for each segment, I iterate over each point. And as a point has this time, I can calculate my delay, at which time I should schedule or draw this point. I have an initial state. This is like at the beginning an empty signature, and then I need some work. So delay, state, and work. And then I can use my scheduler to schedule this work. So what I did previously, I was just console logging every point. What I will do now is I will take the initial signature, I will provide all my informations like the delay and everything, and then I will update my signature on the right side, on the second panel, drawing panel. And if I do this, and I draw something, and I click this Animate Real-Time button, you see that it draws in real time on the right side. Not only in real time, it is also including breaks. Now I did a break, and now I draw again something, and if I reschedule this, you also see that I include all the time in between my drawings, all the breaks. But what happens if I click this button multiple times very fast? Then you see that my animations overlap each other, and they are not really nice. So we should handle this. How could we handle this? Well, there is this subscription.add method that I explained you some time ago. And I could use this subscriptions add method to fix this bug. So I have a drawing subscription here, which is just a new simple subscription. And then I can use the subscriptions add method. And as you know, if I call schedule, I return a subscription, and this subscription is now added to my drawing subscription. What else do I need to do? I need to reset or unsubscribe from this subscription whenever I reschedule a new animation. And this is done here, this reset subscription. Perfect. So now let's run the code again. I draw something, I click this Animate Real-Time button, and when I click it very fast, you see I don't mess up my animations anymore. I can really click it multiple times, and whenever I click it, it starts from scratch. Very good. What else can I show you? The next thing, let me quickly check, is the virtual time demo for sure. So back to this example, I have this animation and I can draw a signature, I can animate everything. And on the right side, I always have to wait as long as my drawing took, as long as this time I have to wait to see the final result. What if I want to print the drawing immediately and don't want to wait for so long? Then I could use Virtual Time Scheduler to eliminate time. And there is a second button. This second button is called Show Immediately. And if I click this button, I provide true here. If I have true here, I use, instead of the async scheduler, the virtual time scheduler. So this is the only change. Instead of this variable, I use this variable under scheduler, and then I can try to click my second button. So I draw something, Animate Real Time will work, and if I click the Show Immediately button, nothing happens. Why is this the case? Well, as I showed you at the beginning, if I use Virtual Time Scheduler, there's one more thing that I have to know. And this is, whenever I say I'm done and now I want to run everything without no time, I have to call the flush method. And when I call the flush method, and I wait until this is redrawn, I can basically draw everything in 0 time. So this is animated, and now I will clean it and click the Show Immediate button, bam, and it shows without any animation. I did no changes in the code, nothing, but just providing another scheduler. I guess this is another very good example that shows how powerful these things in RX are. Very good. Let's recap. What I showed you is an overview of our schedulers. What are schedulers? How can you use them? The different types of schedulers. A very important information: if you provide a delay, you will always fall back to the asynchronous scheduler. And then I also showed you how to use them manually to schedule some animations or whatever. Of course, there is a lot more. For example, I didn't introduce you into the test scheduler, but I have only 50 seconds left, so I guess that's not enough time to talk about this. That's basically it for my presentation today. As I told you, everything that you saw here is reverse engineered. There is no documentation outside. So you can consider yourself now as an expert in RxJS schedulers. And what do you do if you are an expert in some technology? You go to your boss and ask for a salary raise. Thanks a lot for your time, and I will use the last 40 seconds to tell you that I have this tradition. Whenever something really special happens in my life, I shave a mustache. If you realized it, currently I'm wearing a mustache. This is because of this conference here. I'm super happy to be here, and just to give you an example that you can compare it with, the last time when I shaved myself a mustache was the wedding of my sister, or the birth of my first nephew, so something really important. That's the last tiny bit of information for you, and have a nice day.